So in this video, we're doing some stuff by hand, which is cool. But we're given the 5-number summary already. We didn't have to do it. So we had 40 data values, which we don't have that list of, but that's okay. And the 5-number summary is given to us, which consists of the minimum, the first quartile, the median, which is also the second quartile, the third quartile, and the maximum. So we are given our 5-number summary there. We want to create a box and whisker plot for the given 5-number summary, which is not bad because a box and whisker plot basically consists of a 5-number summary. Now, we're given this number line here, but there are no values along it. And in order to do this accurately, we need like a scale. So my minimum value is 43. It goes all the way up to 388. So I'm gonna gist it. I'm gonna probably count by just let me see. We're gonna count by, I was thinking of doing 50 just to get a gist, but let's do 50s. So we'll count by 50s. So this is gonna be 50, 100. This is just to create the scale. 150, 200, 250, because if I'm doing a box plot by hand, 300, hopefully I have enough space. Yeah, 350, and then we'll go to 400. And technically, obviously, this number line continues in both directions, but we're focusing on where our data lies. Now, the reason that I had to have this is for accurate placement of this, or at least semi-accurate, because it's not going to be perfect. But I like to start with my box and whisker plot. So my box starts at the first quartile, which is 97. And obviously it's not going to be perfect, but it's approximately here. And I like to, if I'm doing this by hand, write my actual value. This is my Q1, and my Q1 is 97, which should be close to 200. But again, figure not drawn to scale perfectly, just to get an idea of the distribution. And then my box ends at my third quartile, which is at 319.5, which is all the way over here, approximately. So this is my Q3, my third quartile, which is 319.5. So the box of the box and whisker plot is now able to be closed. Beginning of the box is Q1, end of the box is Q3. Now my median, which is my Q2, is at 207, which is approximately here. So that's going to consist of a vertical line, which is at Q2, or my median, which is 207.5, which is approximately there. And then my box is done. My whiskers now, this is an ugly 7. My whiskers go from the end of the box here to the minimum, which is at 43, approximately here. I'm going to write the min, which is 43. This is the whisker on the left side. And then the whisker on the right side is going to go from the maximum from the third quartile to the maximum at 388, which is like here. So this is my maximum, which is 388. So this is the approximate sketch of the box and whisker plot. Now, if I didn't have the scale, you can see like there'll be even less accuracy with like how far apart some of these lines and whiskers are. Okay, so that's not bad. That's just the box and whisker plot, and you can look at that and determine the distribution. You can get an idea of skewness. You could say it's approximately normally distributed. You can go into detail based on that. More information that I could determine from the 5-number summary is called the IQR, the interquartile range. If you ever see IQR, this is the interquartile range, and it's very simple. It's just taking Q3 minus Q1. So if you are given your 5-number summary, which we are here, I'm just taking my third quartile, which is Q3, in this case 319.5, and I'm subtracting from that my first quartile, which is 97. And I don't have the calculator here to show you, but obviously that's a very nice and easy calculation. So go ahead and do it. And then I have a 222.5. Something that's important here, and I like to see it on the projects as well. When you guys talk about a 5-number summary, you could use that and the IQR to talk about outliers and calculate whether or not you have them. And so you want to find the lower boundary for outliers, which is the lowest value that's not an outlier, and the upper boundary for outliers, which is the highest number that's not an outlier. So if I calculate whatever I'll show you my work, but whatever I calculate here, anything below this number is considered an outlier. Whatever I calculate here, anything above that number is considered an outlier. So the way that you find the lower boundary for outlier is you're going to take your Q1 and you're going to subtract 1.5 times the IQR. Okay, so my Q1 was 97, my first quartile, and I want to subtract from that my 1.5 times my IQR, which I just determined was 222.5. Okay, so I'll give you guys a chance. You could kind of plug that into your calculator, 97 minus, put parentheses around the 1.5 times the 222.5, and I got a negative number, negative 236.75. And check that. And for me, it looks like the lowest boundary for outliers, the value that is the smallest from the set of data that is not considered an outlier is this negative number. So anything less than this is considered an outlier, which my minimum is 43. So I can tell without even having the set of data that there are no values from that data on the low end in terms of outliers. There are no values that are less than this. And usually if I have a negative number, you know, especially if it's representing blood sugar levels, there's nothing that's going to be negative. My upper boundary, I just do Q3 plus 1.5 times my IQR. So my Q3 was given to me as 319.5, and I want to add 1.5 times my IQR, which we determined was 222.5. And this looks like, I guess I could bring it down here. So go ahead and do that on your calculator, 319.5 plus parentheses around the 1.5 times the 222.5, 653. I got, check my numbers. Oopsies. 653.25. And so what that value represents is the highest number that from the data set that's not an outlier. So any blood sugar level that's greater than 653 for this set of data would be considered an outlier. But if you look at the maximum here, the maximum from the data set is not bigger than this. So I'm going to say that there are no outliers, even without having the set of data. There are no outliers for it based on these calculations. And if you look at this box plot, it kind of goes along with that. I don't see any like positively or negatively skewed cases. It looks almost normal, like normally distributed. I don't see anything pulling it to the right or to the left, which would kind of also be an indicator of an outlier. So this is all kind of going together to tell me the same thing, that there are no outliers for this situation.